Hello everyone, welcome to lecture 5 of our course Basic to Advanced Level Real Analysis. In this full course, we have divided the course into 4 parts. Part 1, Part 2, Part 3 and Part 4. Part 1 and Part 2 होगा iit-jam and csir-net both के लिए, and Part 3 and Part 4 होगा only for csir-net. The full syllabus of the course is like that. पार्ट 1 में हम लोग कवर करेंगे फंक्शंस, रियल नंबर सिस्टम, सीक्वेंस सीरीज, कॉन्टिन्यूटी एंड डिफरेंशिएबिलिटी। पार्ट 2 पे हम लोग कवर करेंगे रीमेन इंटीग्रल एंड टोपोलॉजी ऑफ रियल नंबर्स। पार्ट 3 में हम कवर करेंगे काउंटेबल सेट एंड अनकाउंटेबल सेट, एंड पार्ट 4 में कवर करेंगे सीक्वेंस एंड सीरीज ऑफ फंक्शंस एंड बाउंडेड वेरिएशन। सो अभी हम लोग पार्ट 1 में है, जहाँ पे हम लोग पढ़ रहे हैं फंक्शंस, रियल नंबर, सीक्वेंसेस, continuity and differentiability. So in the last lecture, our topic of discussion was properties of supremum and how to find LUB and GLP of a set. हम लोगों ने देखा था कैसे सुप्रीमम और इन्फीमम ये सारी सेट को हम फाउंड कर सकते हैं in the last lecture. So please watch the video if you want to know the details. Now in lecture 5 today we will cover following 5 topics. In the very beginning, we will cover sequences. What is the sequence? Both bounded and unbounded sequences with examples and theorems. उसके बाद हम लोग देखेंगे what is convergent sequence, and after some example we will see sandwich theorem, what is sandwich theorem and application of sandwich theorem. उसके बाद हम some important limits देखेंगे, limit x to the power 1 by n to the power 1 by n and limit 1 plus 1 by n to the power n. उसके बाद हम लोग देखेंगे रेशियो टेस्ट क्या होता है, and by रेशियो टेस्ट we will find that limit, and at the end we will see the monotone convergence theorem and its application. So अब लोग जो बुक यहाँ पे पढ़ सकते हो वो है फर्स्ट रियल एनालिसिस बाय स्कीमा, उसके बाद मैथमेटिकल एनालिसिस बाय मालिक एंड अरोड़ा, एंड एडवांस लेवल बुक रियल एनालिसिस बाय बाटले एंड सर्बर्ट। ऑल्सो जो कुछ हम इस वीडियो में डिस्कस करेंगे उसका नोट अगर आप मिलना चाहते हो तो हमारे www.mathnotespedia.in वेबसाइट पे आप लोग नोट डाउनलोड कर सकते हो विथ फ्री ऑफ कॉस्ट। लिंक आपको डिस्क्रिप्शन में मिल जाएगा। आप लोग हमारा व्हाट्सएप ग्रुप भी ज्वाइन कर सकते हो फॉर फ्री नोट्स। एंड इफ यू हैव एनी डाउट्स और क्वेरी यू कैन ईमेल मी एट mail@mathnotespedia.in. आई विल ट्राई टू सॉल्व योर डाउट्स. सो लेट्स स्टार्ट टुडेस लेक्चर. So what is a sequence of real numbers? A sequence of real number is a mapping from domain n to real number set R. We generally denote this sequence as second bracket xn or first bracket xn. So for each value of n from natural number set 1, 2, 3, 4 like this, we will get the sequence as x1, x2, x3. Each x1, x2, x3, x4 are the element of R. That's why we are calling this a sequence of real numbers. We will consider only sequence of real numbers here. We do not consider sequence of complex number here. Now, difference between a sets and a sequence. Remember that a set must contain distinct number of elements, but a sequence may contain same element again and again. For example, if you consider a set like this 1, 1, 1, 1, then this is a sequence which is sequence of constant number 1, a constant sequence, but as a set it only can be written as singleton 1. So this is a set, whereas this is an constant sequence. Okay, this is the difference between a set and a sequence. Now let us see some example. The example is sequence 1 by n. So for n is equal to 1, 1, उसके बाद half, 2 for 3, 1 by 3 for 4, 1 by 4. If you consider minus 1 to the power 1, so for even numbers of n you will get 1, and for odd numbers of n you will get minus 1. So the sequence will look like this: minus 1, 1, minus 1, 1, minus 1, 1, and continuing this. If you take 2 to the power n, then the sequence will be like this: 2, 4, 8, like this. Okay. Now types of sequence. There are two types of sequence in general: bounded sequence and unbounded sequence. We will discuss what is bounded sequence. So a sequence is said to be bounded if there exists an m such that mod xn less than m. That means minus m less xn less m. अगर xn फॉर ऑल n होना पड़ेगा. अगर xn ऐसा हो जाता है, दो बाउंड मिल जाता है, एक अपर बाउंड m एंड लोअर बाउंड माइनस m, then we will call the sequence bounded sequence. For example, 1 by n sequence are bounded because every element of this sequence are greater than 0 and also less than 1. So 0 less than xn less than 1 for all n. So there is a lower bound and there is an upper bound. That's why this sequence is bounded. Also minus 1 to the power n is also bounded. Why? Look at that, every sequence member are lesser equal to minus 1 and greater equal to minus 1 and lesser equal to 1. So lower bound is minus 1 and upper bound is 1. That's why this sequence is also bounded. Okay. Now what is unbounded sequence? A sequence is said to be unbounded if it is not bounded. Okay. For example, 2 to the power n, यहाँ पे लोअर बाउंड तो 2 होगा. each element of these sets are greater equal to 2, but there is no upper bound. Okay, sorry, each element are greater equal to 2 and but there is no upper bound. So this sequence is not bounded above, and hence this is an unbounded sequence. Now what is a convergent sequence? Any sequence xn is said to be convergent if for every epsilon greater than 0 there exists an m belongs to n such that xn minus some real number less than epsilon for all n greater equal to m. That means xn will tend to L if the difference between them will be smaller than epsilon for some n greater equal to m. Then we will call xn is equal to L. Limit n tends to infinity, xn is equal to L. Geometrically, this means that a convergent sequence comes in the neighborhood of the limit L after a certain stage. That means in the real line, if you take x1, x2, the sequence members dot 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 like this, then after a some value of n, the sequence member will come in the limit range in the neighborhood of L. Okay, for all n greater equal to some m. Then we will call xn tends to L. Okay. For example, consider the sequence 1 by n. This sequence starts from 1 and goes to 1 by 2, 1 by 3, 1 by 4 like this, and you can see that from 1, उसके बाद 1 by 2, उसके बाद 1 by 3, उसके बाद 1 by 4. Like this, after a certain stage, the sequence will comes in the neighborhood of 0. That's why this sequence 1 by n converges to 0. Okay. Now remember that limit of a convergent sequence is always unique. Okay, remark is that limit of a convergent sequence is always unique. So if you have two limits L1 and L2 of a convergent sequence, then we must have L1 is equal to L2. Okay, you can see the proof if in any standard book. We will not going into the proof. Okay, next theorem is that every convergent sequence are bounded. Convergent sequence is always bounded. But note that if a sequence is not bounded, then it is not convergent. It is obvious. If convergent, then bounded. So if a sequence is not bounded, then it will not be a convergent sequence. For example, 2 to the power n, we have already seen that the sequence is not bounded. It is not upper bounded, so it is not bounded. That's why this sequence is not convergent. Okay, so by seeing boundedness, we can say is sequence is convergent or not. The next is the converse of this statement is not true. For example, take -1 to the power n sequence. It is already we have seen that this is bounded, but the sequence is not convergent. Why it is not convergent? Because it have two limits, -1 and 1, -1 and 1, and we have already seen that the limit of a sequence must be unique. So here limit will not be unique. So as the limit is not unique, that's why this sequence is not convergent, although this sequence is bounded. Okay, now let us see some example of important limits. The first example is that limit n tends to infinity x to the power 1 by n is equal to 1, where you must take x greater than 0. Okay, the next limit is that limit n tends to infinity n to the power 1 by n is equal to 1. We will see this limit after few times. The next important limit is the geometric limit. Limit n tends to infinity x to the power n is equal to 0 if mod x less than 1. That means if -1 less x less 1, then x to the power n का लिमिट जो हो 0 होगा. अगर x is equal to 1 होता है, अगर x is equal to 1 पुट करते हो, तो you will get the limit as 1. And if mod x greater than 1, that means x less than -1 or x greater than 1, then the limit will be infinity. Okay, please remember these limits. The next limit is limit n tends to infinity n x to the power n, that means n is multiplied here, then it will be 0 if mod x less than 1. Okay, the next important limit is the divergent limit. Limit n tends to infinity 1 plus 1 by 2 plus 1 by 3 plus 1 by n is equal to infinity. Okay, then the last example is the limit n tends to infinity 1 by 1 plus n to the power n is equal to a, the exponential limit. Okay, now let us see some important theorems. Remember that if xn and yn are two sequences, convergent sequences, then their sum and their product is also convergent. But remember that the converse is not true. For example, if you take xn to the power xn is equal to -1 to the power n and yn is equal to -1 to the power n, then their product will be -1 to the power n plus n is equal to -1 to the power 2n is an even number, so it is as 1, and so sorry यहाँ पे 1 होगा. So this is a convergent sequence, but you know that both xn and yn are not convergent. So here xn and yn convergent, but the converse xn and yn are both not convergent. That's why converse are not true for the product. Okay. The next is if xn tends to x and xn greater equal to 0, then the limit x also greater equal to 0. Okay. But remember that if xn strictly greater than 0, then the result may not be true. For example, if you take xn is equal to 1 by n, then observe that every xn greater than 0, but here xn tends to 0, which is strictly 0 is equal to 0. We can't say here the limit x greater equal to 0. That's why if xn strictly greater than 0, then this result is not true. It is only true if xn greater equal to 0. Then if xn tends to x, then x also greater equal to 0. Now, what is sandwich theorem? Let xn, yn, zn be sequences such that xn lesser equal to yn lesser equal to zn, such that xn tends to L and also zn tends to L. Then the middle sequence also tends to L. Okay. Using this sandwich theorem, we can prove that limit n tends to infinity sin n by n is equal to 0. How can we do this? Observe that we know that minus 1 lesser equal to sin n lesser equal to 1. That means sin n is bounded sequence, we know that. Then if we divide it by n, then we get minus 1 by n lesser equal to sin n by n lesser equal to 1 by n. Now if you n tends to infinity, then limit n tends to infinity minus 1 by n is also 0, and limit n tends to infinity 1 by n is also 0. That's why this sequence goes to 0 and this sequence also goes to 0. So by sandwich theorem, this sequence will also go to 0. That's why limit n tends to infinity sin n by n is equal to 0. Okay. Now observe a very important test, which is ratio test. Remember that if a sequence xn such that limit n tends to infinity xn plus 1 by xn is equal to L, then the limit of xn will be 0 if minus 1 less L less 1. Okay. अगर L का वैल्यू अगर माइनस 1 से 1 के अंदर होता है तो सीक्वेंस 0 पे टेंड करेगा, एंड इफ L greater than 1, then the limit will be infinity. By using this ratio test, we will calculate this limit n tends to infinity factorial n by n to the power n. So for evaluating this limit, let us suppose xn is equal to factorial n by n to the power n. Then put n plus 1 in place of n, then you will get xn plus 1 is equal to factorial n plus 1 by n plus 1 to the power n plus 1. Then the ratio xn plus 1 by xn will give you this, and if you simplify that, you will get n plus 1 into n factorial by n plus 1 into to the power n by n plus 1, and there is n to the power n by n factorial. So by cutting n factorial and n plus 1, you will get n to the power n by n plus 1 to the power n. And if you take 1 by n plus 1 to the power n by n to the power n, you will get that 1 by 1 plus 1 by n to the power n, which is this 1 by 1 plus 1 to the power n. Okay. Now if you take both sides n tends to infinity, then you will get the value L limit as 1 by e, because 1 by 1 plus 1 to the power n goes to e. We have already seen that. That's why the limit is L is equal to 1 by e, which is less than y, because e का value होता है 2.71 something, so 1 by e is less than 1. That's why as the limit is less than 1, so by ratio test we can say that the limit xn goes to 0. So by limit test this limit will be 0. Okay. Now let us see the second version of ratio test. The second result says that if the limit xn by xn plus 1 by xn is L, then xn to the power 1 by n will be the same value L. Okay. Using this result, we can prove that limit n tends to infinity, n to the power 1 by n is equal to 1. So to prove that, let us take xn is equal to n, then xn plus 1 is equal to n plus 1, then the ratio will be n plus 1 by n, which is 1 plus 1 by n. Okay. Okay. Then if you take limit n tends to infinity, you will get the limit as 1. Okay. So by the second version of ratio test, you can say limit n tends to x to the power 1 by n is equal to L, and hence limit n tends to infinity, n to the power 1 by n is equal to 1. Okay. Now what is monotone sequence? Remember that a sequence xn is said to be monotonically increasing if whenever n1 less than n2, you will get n1 less than xn2. That means if something 2 less than 3 we know, then x2 must be less than x3. That means the sequence increasing, x1 will be less 2, x2 suppose 3, x3 suppose 4, that like this the sequence value must be larger from the previous value. Then we will call the sequence is monotonic increasing. Now a sequence is monotonically decreasing if you get n1 less than n2 but xn plus 1 greater than xn2. Now when a sequence is either monotonically increasing or decreasing, then we call this sequence is a monotone sequence. Okay. So for example, if you take 2 to the power n, sequence is monotonically increasing. Look at that, 2, 4, 8. So subsequently the sequence value are increasing, every next value are greater than the previous value. So this is a monotonically increasing sequence. Also 1 by n is monotonically decreasing because every next element is lower than the previous element. Half is less than 1, 1 by 3 is less than half. So the sequence is monotonically decreasing. Now what is monotone convergence theorem? The monotone convergence theorem says that if xn is convergent, then it is bounded. So a monotone sequence xn is convergent if and only if xn is bounded. So if a sequence is monotone and it is bounded, then it is convergent. Okay. Remark that if xn is increasing and bounded above, then the limit of the sequence will be the supremum of the set xn, n belongs to n. Okay. So if you consider the any set which is increasing x1, x2, xn, then if it is bounded above, then by LUB property of real numbers, we have already seen that in lecture 2 or 3 that the sequence will be have a supremum. So that's why the limit is the supremum here. Similarly, if a sequence xn is decreasing and bounded below, then the sequence is also convergent and the limit of the convergence will be the infimum. Again, by LUB property, if a sequence is bounded below, then it will have an infimum, and by this theorem, the limit of the sequence will be that infimum of the set xn such that n belongs to n. So if a sequence is bounded above, then the limit of the sequence will be supremum of the set, and if the sequence is bounded below, then the limit of the sequence will be infimum. For example, if you take the sequence 1 by n such that n belongs to n, then the sequence is 1, 1 by 2, 1 by 3, 1 by 4. We have already seen that this sequence is monotonically decreasing, and this is a by bounded below by 0, because every element of the sequence is greater than 0. So it is bounded below. Okay. So as it is bounded below, the limit of the sequence will be the infimum value of the set this, and we know that the sequence, this set has infimum is equal to 0. That's why here limit n tends to infinity xn will be that infimum is equal to 0. That's why the sequence 1 by n tends to 0. That's why this limit n tends to infinity 1 by n is equal to the infimum of the set n is equal to 0. Okay. So that's it for now today. We have to stop now. In the next lecture, we will discuss the sequence subsequences, where we will discuss the lim sup and lim inf concepts. Till then, goodbye. We will see you in the next video.